That's how long he's in the air. He's moving 5 meters per second for that long. So we know something pretty cool. We know that his horizontal, this is his horizontal velocity, and his horizontal displacement. So it's horizontal displacement. It's this horizontal displacement over the change in time. So what we can do is we can figure out what his displacement is in the horizontal direction by just taking delta t times Vx. And that'll give us our displacement in the x direction. It should be a subscript here, not a big X. These are just subscripts to let you know that this is in the x direction, that's in the x direction. So if I put in 4 seconds here, times our velocity, which is 5 meters per second, you're going to get our delta s in the x direction. This is how far he goes from the base of the cliff. So it's 4 times 5. I think you can do this in your head. If not, we got some problems. It's going to be 20 meters per second. That's our delta. Oops. That's our delta x. Delta s in the x direction. What are the vertical and horizontal velocity vectors just before the boy hits the ground? What is the resultant velocity vector? So his horizontal one is given to us already. That's already 5 meters per second, so we know that. So it's 5 meters per second. Now our vertical one, we need to know what our Vy is, our final velocity is right before he hits the ground. And to know that, we can use another equation that we learned in the last unit, which is awesome. We can use, which one do you want to use? It's really whatever one you want to use. I'm going to use this one. Delta S equals Vf delta t. We know what our delta t is, right? Minus a 1/2 a delta t squared. So we just need to find what our Vf is. In this case, it'll be our Vf in the y direction here. Yeah. So we can do that. Or we could also do another equation if you want to, which is somewhat simpler, which is the acceleration is delta v over delta time. And so that's going to give us our Vf minus u over delta t equals a. You can see this one's a little bit easier than this one, but it'll give you the same problem, or the same answer. So our Vf, we want to solve for Vf, it's going to be a delta t plus u. You can check that algebra if you want to. That's the equation we want to use right there. You plug in our acceleration here. You plug in the initial velocity, which would be 0, so that just cancels out. So it's going to be acceleration times the time it's spent. And this is going to be a negative vector since it's going downwards. So I can make this into a different color. Let's use tangerine. There it is. It's going to be in this direction right here. So this is going to be, I'm just going to write this out, negative 9.81 times our time, which is 4 seconds. And this is going to get us negative 9.81 times 4 is 39.24. I'm not going to round anything yet. 39.24. I'm going to wait till the very end. It'll be negative 39.24. So this makes, so you've got this component here and this component here. You can add these two together. The way you add them is tip to tail. So I drew this incorrectly. I should have put this right here. Ah, there we go. 39, this is going to be negative 39.24 meters per second. Should not be like this right here. In fact, I'm just going to erase that. And you can say, what is the resultant vector, velocity vector? The resultant velocity vector will be whatever this hypotenuse is. And you can do a squared plus b squared equals c squared to figure this one out. You can find the angle by using the inverse tangent, which is really cool. Inverse tangent of the, what would it be? TOA. So it's the opposite. So we'd be finding this angle right here. It would be the opposite side over the adjacent side. So you can solve that. It would be 5. I'm really squeezing this in here. It would be 39.24, negative 39.24 on the top. So I'm just going to write A, O over A, the opposite side, which is this one. That's O, and this would be A. You can find out what the angle is. All right, I don't have the answer right in front of me, and it's going to take too long to fit on the video, so good luck solving that one, and good luck with the practice problems. That's it for me. Bye for now.